Okay, so I'm here to talk about a visual condition survey and report that the BBA put together and published about 3 years ago. My report today is really just about an overview of that service life report. What we found were some of the common factors that affect service life. I'll get into service life as well, and that mix of things that you need to actually have a reasonable service life. I'll also do something that gets talked about a lot, and that's these differences between the generic types and whether one can perform better than the other. Now, I'm not going to break it down into all the generic types, but I am going to just give you an overview of a broad cut and split between the cold and the hot. And by that I mean thermoset and thermoplastic. So that's really the objective for the slide. I will start off just first of all with this service life mix. But these are some of the things that if you want a high friction with a pretty good service life, these are the kinds of things that you're going to want to have in that mix. We actually took the bull by the horns very early on. In fact, 20 years ago when we first published a certificate for high friction, we said at least 5 years. And we took into account all of this on here that we thought was applicable. Have we got durable systems? Have we got regulation? Have we got an evaluation process that continues throughout its life? And by life, I mean not just from when it was actually approved and assessed, but also as that approval continues. It's consistency. So what happens there? How do we manage that? Can we evaluate and measure consistency through auditing? Practical installation methods. Again, Greg and Steve, I'm sure, have already said about how you really do need some methods that are applicable and practicable and that can be consistently applied. So having something in place that measures, monitors that and makes sure that that's consistent. And then, of course, industry best practice. So is there anything out there in terms of best practice that allows all of that collection to be brought together and applied to the high friction and that service life? Well, so a durable system. We didn't just create an assessment plan and then say, come on then guys, develop something. Actually, what happened was there were lots of high friction surfacing materials already out there. And what they didn't have was a route to approval so that they could be used on the national network, on the national local network or on the strategic network. So we sat with Highways England, with Adept, with industry and developed a technical assessment. Once that was in place, we had clause 924, which is the MCHW, which I'm sure all of you are familiar with, which is for high friction systems. I'll do these as two. So evaluation and consistency. So once we've done that technical assessment, and again, thinking about what you need to actually measure performance. So obviously there's anti-skid. Wear machine we use, which does a simulation of a number of commercial vehicles per lane per day, and it simulates so many thousand. You can actually gauge from that, to a certain extent, how many vehicles in real life, and of course, how long it might be down on the road. There's laboratory tests where we take samples and put them on slabs, and we measure skid resistance using the pendulum. We also do a 2-year trial, which measures the performance at 6 monthly intervals over 2 years. Performance being skid resistance, texture depth, and its visual condition, and wear characteristics as well. So it's lab and it's on-site, it's in situ. So the technical assessment does that. 924 says if you want to use it on the strategic road network, you must use something that's gone through that technical assessment. Beyond that, the BBA then said, well, if you want to carry on with your approval and have that certificate that says you can make that 5 years, you've got to make sure that you do post-certification re-evaluation. So every 3 years, we would then take a look at some of the sites that have been installed in that 3-year period or before that. So we can develop a database which gives us information about how something's evolved, and we have traceable information as well. The post-cert audits include office visits as well. So we'll go and visit the installer and the manufacturer and check what they're doing there. So all the paperwork that's associated, things like laying records, Tim, the kind of thing that you said may not be available at your end, it should be, and we will audit to make sure that it is at the office of that installer or at the office of that manufacturer if they're one and the same. So there's a lot of information behind that certificate and behind this process that allows us to make a statement about service life. The installer's scheme, I'm talking about two things here really. So you've got the manufacturer who produces, makes the sticky stuff, and they go through that approval process. They need to show that there is someone who can install it. They need to show, they being the manufacturer, that they've got a method in place that allows someone to install it. That someone is an installer. Now, once that manufacturer has said, here's my method of installation, here's the installer that I want to install it, we will then go out and go, right, okay, let's see you install it. Let's use this method that's been put together and see how you get on. Once they've done that and shown us that they can, we will then continue to monitor those installers all the time that that certificate for the material remains valid. So there is a continued process of constant monitoring behind the scenes to support that certification. And then, of course, you have the likes of the RSTA and their members who have signed up to get involved with MVQ training, so that's all been set up. So even beyond what we do at BBA under the HAPAS scheme for high friction, where we go and monitor and audit installers, monitor and audit the manufacturers, you've also got NVQs, which are industry recognised qualifications for all those who are going out and doing this business, installing these products. So for that HFS service life, when we said 5 years in that first certificate, all of that was in place to move it forward, to give us the confidence. A few years ago, we understood from industry, we have a committee that gets together a couple of times a year, more so if there's any issues, to discuss how the certificate is working, how the assessment's working, deal with various issues, improvements, things that we can do to change and make this a much better, more robust scheme. And one of those meetings, it was, well, there is this perception that some sites aren't actually performing. So it was like, okay, what can we do? We explained, well, we already say 5 years. We've already got that service life mix covered. Is there anything else that we can do? And we agreed we would do actually quite a big survey, really bring in a lot of sites and information, because some of it was, as we've used this term, anecdotal. I know a site that did this, I know a site that failed here. There was never enough supporting evidence to give us enough confidence to say, okay, maybe there is a problem here. I know TRL did one for thin surfacings, and we thought maybe we could do something very similar here. So the only organisation with access to loads of sites, actual sites that are related to BBA HAPAS was the BBA. So we said, okay, we'll do that. So over a couple of 2 years period, we collated all that information together, and we managed to put together 327 inspections on 285 sites. I'll just clarify that. That is where we were when we started doing this seminar, which was last year, I think. When the report was issued in 2015, we were on about 302 and about 272 sites. So we're adding to it, but not in the volumes that we were. But we gathered all of this from our 3-year reviews. Remember, back to the service life mix, all that information we gather from each of those assessed products. From the routine surveillance, so the surveillance associated with the approved installers, we were able and have access to the installer records. We have access to those 2-year trials, so we've been able to keep all of those records, and we brought them all together under one database. The sites themselves, that I'll show you a chart on shortly, 12 months and greater, up to about 12, 14 years. The one that we have just comes up to about 12 years. The sites are located throughout the UK. As I say, the audits are, well, the HFS scheme is for manufacturers across the UK. So you've got Scottish sites, Northern Irish sites, Welsh sites, English sites, all over the country. Random selection. We didn't go out and say, let's have a look at a load of bad sites, let's go out and have a look at a load of good sites. We just said, here's 400 or 500 sites. One of our inspectors is going to Scotland. Let's give him Scottish sites. And he can spend some time up there trying to find them and do the mark on them. And of course, because they're from our database, we know that the sites are traceable to BBA HAPAS, which is one of the key things, traceability. We didn't want to be looking at sites we didn't have any data on. So the observations were based on Appendix F of the HAPAS guideline. Again, that's available on our website if you want to have a look. The defect survey that we do and the marks associated with that. They were completed by BBA inspectors and project managers. Some of those also included panel inspectors because they extended 2 original assessments and follow-up assessments as well. There were 20 plus elements per site, so it wasn't just when it was installed, when we go and visit, what was the weather like. We've got the generic type, certificate holder, installer, location, address, substrate type, condition, at installation, site category, weather, colour. The list goes on. That was pretty epic trying to put all that together. So in terms of the generic groups, so the big 48 there in the amber coloured is basically the type 1 hot applied, and then you've got 2-3% at the top there. That's a type 2 and type 3 hot applied. There were some of those included in the survey. The rest are just split between the thermosets of the cold applied. And that split is pretty representative of what's going on out there. We do believe, and again, this is from industry as well, that you get a kind of slightly greater percentage of thermoplastic, and then the rest of the thermosets, as you can see, they split between there. So this was one of the slides that we used, and it's in the report. It gives you an idea of, again, because of service life being this thing, this is visual condition. If we were going to apply visual condition to service life, what would it be? So 7 at the top is excellent, 6 is good, 5 is moderate, 4 is acceptable, 3 is serviceable, 2 is poor, and 1 is bad. And as you can see, 4 being acceptable, we decided acceptable would be our line. Although some say maybe we should use serviceable, but we wanted to shift it up 1 to acceptable. Who would stand there and go, yeah, that's all right? So we shifted it up 1 to make sure that we captured only those. The line where the red line there represents thermoplastic, it cuts around the 8 years, and the thermosetting shifts up further, a lot higher, and that probably splits the line somewhere around 14 years, something like that. So at the BBA, and we have to sit on the fence a little bit on this, because we're looking at a scheme that was set up to bring in generic types. We didn't really want to split them out, but this for you guys is quite valuable, because if you're trying to make a decision as you move through your laying season, your season of maintenance, you've got to make some judgments as to what you want to use, and obviously that links in with budgets, etc. But of course at the top of the list is risk. So this is just another representation of that. This is marks awarded for all sites, generic types and ages. Now there's going to be a few bar charts like this, and these are in the report online. So then there's a lot more of these. So have a look and pick and choose ones that are maybe hopefully going to help with your perceptions. But everything, we're hoping that everything weighs this side. Excellent, good, moderate and acceptable. So this is all ages, all sites, all generic types. Out of all of those inspections that we did in those sites, 82% were above acceptable. And I'm not going to tell any of you if you've got experience of sites that were poor and like 2 years that it's a very small percentage, because that is what's happening on your network and what's happening to you. But we went out and did a random selection, just went around the country, and this is what we found. So we did find poor sites, we did find bad sites, we did find suspect ones, but the majority that we saw were actually in reasonable condition. So then we split it between the two, and again, they're all kind of to the left of that chart. What we have reported in our online report is that generally we find with thermoplastic, whatever the age, whatever how it looks, we tend to find that you get more good to moderates than you do good to excellence. And I think that's just because thermoplastic's the nature of the beast, the way they're applied. They don't look smooth and nice and flat like a thermosetting. They have those ridges and joints, and all of that can make them start to look a bit, not as good. One of the things that we talk about generic types and where they work and where they don't. We applied a winter-summer season in this as well. Thermoplastic, the hot ones, tend to be used if you've got wintry conditions. You try to avoid it, we all try to avoid it, but sometimes you just can't. You've got a window, you've got a TM, everyone's there, it's stopped, get in there. But this does kind of give you a flavour. If you apply anything, so this is all of them, hots, colds, in the summer you tend to get a very big spike of good. It's not that bad in winter, but you do get good. And that's, if you think about the service life mix, this is where you're engineering into that whole system, not just the product, but everything, the opportunity to have a better, longer service life, or something that looks good. So we split it out with a thermosetting and thermoplastic, and there you see just a marginal drop on the thermoplastic, where it's still moderate, it's still good, still excellent, but you've got these thermosettings all looking very good. This is in the winter. Thermosettings do get applied in the winter, but as I say, you get a good day, you get a good run of temperature, you get a dry period, and then you put it down. With thermoplastic, you can find a window in the weather and go, let's go for it. Maybe, so I hear. I have sat on the committee for about 15 years, so I get to hear a lot of these. And in the summertime, that's just to reiterate that point, thermoplastic and thermosettings looking very good. This is another one which is a bit cheeky, but if you think about, and again, another discussion we have on our specialist group, which feeds in all the information that we use to try and develop this scheme, is clerk of works, having someone else on site to monitor and check. And it doesn't have to be the BBA, but maybe if someone else was there to oversee what was going on, sometimes it may have a little effect on what you're getting on these marks. So visually, comparison of site installations witnessed by the BBA, we've just got that spike on the good, maybe. That does help. But we can't take away that service life mix and what's going on here. To the left, everything is good and moderate and excellent. We haven't got anything going high on that suspect poor bad side. This is for the thermosetting. Again, the witness, you've just got that spike on the good, and then you have that on the thermoplastic as well. Not as high, but still clearly a spike there. Colour does actually make a difference. It doesn't show it there, but this is all sites, types, ages, and generic types. Grey and buff, this is all sites, all generic types. With a thermoplastic, you actually get a higher mark when it's grey. With a thermosetting and a buff, you get a higher mark. From the data set that we have here, from this 327, our inspectors would often mark the buff thermosetting higher than a buff grey, a buff thermoplastic. that visual perception is going back to that is critical to this. It's very influential in how we're making our decisions. Defects identified, no surprises here really. I think we've mentioned cracking, some of this leads to delamination and loss of high friction material. Loss of high friction material includes fretting of mortar and loss of chippings. So we just bunched all that together because that really, once you're on site, sometimes it's all part of the same defect. And we split it out between thermoplastic and thermosetting. You've got loss of high friction material for both, and then cracking is just marginally higher on the thermosetting. This is just general observations. Again, all sites, all generic types, all ages, all marks. Substrate is by far the biggest influence on that visual condition and then that service life of that product. You've got to get that right, and I know the codes of practice pick up all of that, but we are all led by so many other things that go on site, and I hear all of those, and again, I maybe quipped about it when I shouldn't have done, about the fact that, you know, you've got to get in, it's winter, let's find a window in the weather, but sometimes that site needs to be done. You can't delay, you can't wait until the summer to put that down, you've got to do it now. That's just how it is, and that's some of the things that we face, but the service life mix, I think, gives us that position where we can do that. There were 15 sites that didn't make the cut. They were up to 5 years suspect or worse. Installation in unfavourable conditions, complete structural failure of the pavement. We went out to the site and it was an observation that was made. There were cracks everywhere beyond the surf, the HFS. It was out into the other lane. It was quite grim. Defects owing to post-installation work. That's not just your control loops, I think they're called, but reinstatements. You start cutting into these, you know, this is what happens, you know. Overheating of binder. Weirdly, that applies to two. That was a thermosetting and a thermoplastic. We had another where we were looking, we couldn't think, it was right at the top end of the installation temperature. We have in the method statement up to 35. And this was right at the top end of that temperature. The inspector made a note of it because he was there for the installation. We went back to look at that site at the 5-year point. I thought, well, it was inside. Oh, maybe we need to lower that temperature. And then he said, it is surface dressing. The only thing we weren't sure on that was how old the surface dressing was. But surface dressing is a very different beast to an asphalt. It's a very different beast to a hot rolled asphalt. Sorry, an asphalt concrete and a hot rolled asphalt. So a surface dressing may just still be a little bit more lively, and maybe that is why that site didn't quite make the cut. We've had a few where high friction was installed on old high friction. And then we had one where the use was, we saw weird track marks in it, and then my inspector said there was an RAF or an army barracks not far from there, and they might be tracking around on this. I don't know, but they were very weird looking track marks. We thought we'd take another look at that graph and take out all the things that we thought were, you know, it's the kind of thing that you just, a little bit of overheating binder, the substrate issues, the use where there was tracked vehicles. Take all of that out and then redo that graph. And as you can see, everything's shifted up. It wiped out over 40% though of the sites because there are all these other little things that were affecting it. It wasn't down to the material, it wasn't down to the installer, it wasn't down to anything specifically. It was down to all those other things, substrate, cracking, pavement failure, all of those. And it just started to creep back up. But of course your data set went, which was quite frustrating. So visually, we felt actually, from a point of view of this data set that we've gathered, this 300 inspections, 200 on sites, 82% traceable to our systems marked with a visual condition of acceptable or greater at 5 years. So we felt confident, very confident, that that was achievable. Service life greater than 5 years is a realistic expectation, but based on this service life mix, so having all of those things working together. If you've got substrate post-installation work, they are major contributing factors. Those defects that we found, the majority of, were related to that kind of thing. So, I mean, really the further conclusion here is that I think the service life mix looks to have worked. It's picked up a lot of the issues that unfortunately we can't always eradicate, all those variables, but it's done enough, we think, to at least give us that confidence that that 5 years is achievable. And I thank you for your time. Cheers.